Srinivasan. This is Nudal Srinivasan from EC department. Today I am going to take a topic about memory unit. Okay, so in memory unit, this is the basic structure of a memory unit. In memory, there are two important parameters. One is address line and another one is data line. So what is the basic operation of a memory? Memory is to save the data. That means binary data, especially because computer language is a binary language. It can know only ones and zeros. Okay, so we are using a memory by setting and resetting the data. So which is called writing and reading the data. So this is why we are having a read and write lines. Okay, so we are using a k address line. For an example, if we take a k the value of 8, okay, then the value of the total capacity of a memory is 2 power 8. That means 2 power k, which means here we now k is 8, so 2 power 8 is 256 bits. So 256 bits of data can be stored now for a 8 address line. If we increase the number of address lines, then we can increase the memory capacity. Okay, so we are giving a input data lines. When we are giving the input data lines means we are writing the memory. That means we are storing something inside the memory. So when we are having a output data lines, which means we are reading the memory, which means we are going to view the memory and what are all the data stored inside the memory. That's why we are using output lines. So the memories are classified based on the type, size, hardware, material used, everything based on this classification. First one is register, main memory and secondary memory. In second type, sequential access memory and random access memory. Third one is static and dynamic memory, and fourth one is volatile, non-volatile memory. Fifth one is magnetic and semiconducting memory. So these memories are always important for all the electronic devices. For an example, registers is nothing but cache memory, which is used in computer processor, all the processor having a cache memory. Okay, so and the main memory is classified into two types. One is RAM and another one is ROM. So secondary memory is nothing but hard disk. Okay, so in sequential access memory and random access memory, we know that static and dynamic memory. So these are the two types of memory classified by means of RAM. Okay, so static means we are using we are allocating the address sequentially. That is called static memory. And dynamic memory means we are giving or accessing or we are giving assigning the addresses randomly. That is called dynamic memory. And what is volatile memory means when the memory is working, that means we are giving power to the memory, then only that memory will save. If that type of memory is called volatile memory. When the power is switched off means all the data inside the memory is erased. Okay, so in non-volatile memory, the memory even when the power is switched off, the data stored inside the memory won't delete. Okay, so it is otherwise called as permanent memory, is called non-volatile memory. Last one is magnetic and semiconducting memory. Magnetic materials are used in hard disk. That is a magnetic disk. It is otherwise called as hard disk. We are using for a regular purpose. And the semiconductor memory is a chip. Okay, chip based memory. So this semiconductor memory is used as memory card. So now we are storing this video in this semiconducting memory. So next thing is, so what are the different memories? Register memory, main memory and secondary memory. So this register memory available within the CPU, as I already told you, it is inside the processor. It is otherwise called as cache memory. Okay, so in this memory all the operation can be performed easily. We know about the separation of a processor. In processor we have a three major unit. One is memory unit and another one is control unit and the third one is arithmetic logic unit. In the arithmetic and logic unit, it performs all the calculation, okay, mathematical calculation such as addition, subtraction, multiplication and division, as well as logical operation. So all these operations are performing with the help of ALU processor. Okay, all this processing data and output are stored in memory. Okay, so this memory is nothing but registers. Okay, next one is main memory. So this main memory of a computer usually is a semiconductor type. Okay, available external to the CPU. So this main memory can be removable, okay, or detachable. It can be used by any machines. Okay, one machine to another machine, it is transferable. Okay, that type of memory is main memory. Basically main memory is RAM and ROM. Okay, RAM is a chip based memory and ROM is nothing but a IC based memory. So these are the two different memories. Okay, In the main memory, there is a memory location identified by an unique address. So we are assigning an address. Okay, all the memory we need to give an address. Okay, if there is no address for a data, then it becomes a invalid data. Okay, so all the data must be a valid data when only we assign the address. If the data doesn't have an address, means that data is considered as a invalid data. How you are using your Aadhaar card? So if you add an Aadhaar card only, you are a valid citizen of India, or otherwise you are not a valid citizen of India. Like that, your data having an address, then only it is a valid data. Okay, so this is how we are giving the unique address in the main memory. As a storage capacity of the main memory is inadequate secondary memory. Why? Because we are using secondary memory, means the storage purpose. Okay, so it is not an adequate memory, because it being a very fast memory, we are using a very small size of a memory only. For an example, 4 GB, 8 GB or 16 GB memory for a RAM. That is not an adequate for storing a large quantity of data. For an example, images, videos, audios having a very huge data sets. So we cannot able to store in main memory. That is why we go for a secondary memory. Okay, so sequential memory, it is a magnetic tape memory. We know that example. Okay, so that is called sequential memory. Here the allocation of address are sequential. That is why we use sequential access memory. Random access memory is otherwise called as a semiconductor RAM. In this we are having a two types. One is static memory and another one is dynamic memory. Static memory is made up of a transistor and dynamic memory is made up of a capacitor. Okay, static memory allocates addresses sequentially, main memory. Okay, so sequential allocation of a memory is a static memory, and dynamic allocation or a random allocation of addresses, it is called secondary memory or dynamic memory. See, dynamic content changes with the time. Okay, that type of memory is called a dynamic memory. It uses the capacitance we already discussed of transistor as a storage device. What is the operation of a capacitor? Capacitor we can charge and discharge. Okay, here if it is charged means the value is binary value is 1. If it is discharged means the binary value is 0. This is how we are storing the data by using a capacitor in the memory. Okay, so static memory, content does not change with the time. Okay, that type of a memory is a static memory. Okay, so static memory device requires no refreshing. Okay, it doesn't need any refreshing. So because the data are stored sequentially one by one, address are allocated in such a way. Okay, so next one is volatile and non-volatile memory. So volatile memory loses its stored data when power to the circuit is removed. We know that, right? If only when the power is on, that memory will store the data, or otherwise that memory will delete the data. This type of memory is called volatile memory. What is non-volatile memory? Non-volatile memory store the data permanently even after the power supply is turned off. That type of memory is called non-volatile memory. This is otherwise called as permanent memory. Okay, so magnetic and semiconductor memory, these memories are classified based on the materials used for construction. The magnetic memories are constructed using magnetic materials. Okay, so semiconductor memories are constructed out of semiconductor material using LSI and VLSI technology. Example, RAM and ROM. Okay, so ROM, read only memory. This is the basic structure of a ROM, 2 power k into n, which is nothing but k is nothing but number of address lines. Okay, n is nothing but data lines, number of data lines. Okay, here this is the ROM. So this is how we have to write the specification, 2 power k into n. Okay, so this type of, for an example, 2 power 4 into 8. So which means what is 2 power 4? 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 cross 8. This is how we just specify the RAM size. Okay, so data lines and address lines are very important for a memory. Okay, ROM is a semiconductor memory device used to store the information permanently. It performs a read operation and does not have a write capability. Okay, ROM doesn't have write capability. So you have to remember this write capability doesn't have in ROM, okay, because it is read only memory. So in in RAM we can able to write and read both the things, we can do it. Non-volatile, if unpowered, it contains retains, okay, it doesn't delete the data. So ROM is a non-volatile memory also. So that is the important thing. It includes both, especially RAM and ROM. It has a decoder as well as OR gates. Okay, so in ROM, that means in ROM IC, there is an important thing, decoder and OR gate. What is the operation of a decoder? N input lines, 2 power n output lines. So that is the operation of a decoder. Okay, so we know about OR gate. OR gate, which is used for operation of addition, right? So next one is, this is the read only memory. In this memory we are having n address lines given to the decoder. We know the operation of a decoder, it is nothing but n is to 2 power n, n input and 2 power n output. Okay, so based on that the output lines are given to the m bit word. Okay, so that m bit word will given into a tri-state logic, okay, which is nothing but OR gates, okay, which is nothing but OR gates. In this OR gate we are giving another input as a read input, so the output lines will come as m output lines. Okay, so this is the MOS cell as well as a bipolar cell. So there is a memory mapping. Okay, so the memories are structured like a matrix. Okay, just like this a memory will be mapped. Okay, so in the interconnection of this two lines of rows and columns, that interconnected points are considered as important area where the data are stored. Okay, so where the data are stored means that cross areas, interconnected areas. In that area only we are giving this bipolar cell. Bipolar means it is a transistor, BJT, bipolar junction transistor. Okay, by using this transistor we are giving the data. When it is connected to the column wise and row wise, both are connected means then it stores 1. If the loop is open, if the rows and columns are not fully connected, then it stores 0. Okay, it is in transistor. So now next MOS. MOS is nothing but metal oxide semiconductor field effect transistor, MOSFET. Okay, we are using MOSFET. So in this MOSFET the base is connected to the row and remaining thing, so we have to connect, the loop is closed, then it stores 1. So if the loop is open, see there is a opening area, so then it stores 0. Okay, this is how we store the data inside the ROM. Okay, so 32 cross 8 row. So this is the, we know that ROM is nothing but combination of a decoder and OR gates. So we are having a 5 cross 32. What is it? 5 n and 32 2 power n. So for an example, it is 5 means 2 power 5, which is otherwise called as 32. So this is how the system will convert the data. So 0 to 31 is nothing but 32 lines we are having. Types of ROMs. So these are the different types of ROMs. Masked program read only memory, programmable ROM, erasable programmable read only memory, electrically erasable programmable read only memory, electrically alterable programmable read only memory. In this there are two types, EEPROM. We are also having a UEEPROM, right? So ultraviolet erasable programmable read only memory. Okay, so this is the expansion for all the data. So this is how the programmable RAM will look like. So by using a bipolar cells we give the functions. This is the inside of a erasable programmable read only memory. This is a silicon dioxide. SiO2 is nothing but silicon dioxide. So the material is etched within a substrate material, P substrate material. Okay, so here there is having a control gate as well as floating gate. By using a control gate only we can give the data or store the data or read the data. Okay, so the floating gate is used to eliminate or wipe out entire memory. Okay, this is how the symbol So there is a MOSFET using for a gate, drain and source. So advantages of a ROM: non-volatile, cheaper, static, more reliable than RAM, available in longer sizes than RAM, easier to interface than RAM. These are the major advantages of a ROM. Okay. So now random access memory. So this is the structure of random access memory, and we are having an address n bits. This is MAR. Okay. So memory address register. In this register only all the data performing what are all the important data we are recently used apps like in mobile phones. How we see using 3 dots. Likewise, this will store all the recently used informations. Okay, calculations, outputs, inputs, everything is stored in memory address register. That is the RAM array. This RAM array will look like a combinations of rows and columns, just like a matrix array. Okay, this is how the RAM array will look like. Next one is MBR. So MBR is nothing but memory buffer register. Okay, so while buffering, so we need to store some data. That type of a register is a memory buffer register, and in that only we are having a read and write. Okay, so this is the output lines. So RAM internal construction by using binary cell. So we see the binary cell actually, the binary cell having input, outputs as well as select line, then read and write lines. These are all very important for a binary cell. So inside diagram of a binary cell, inside what is the binary cell means, it is a combination of both the logic gate as well as a flip flop. What flip flop it is? SR flip flop. So this will store and set and reset the data. Okay, so by combining this with the different logic gates, we can make it as a binary cell. Okay, so this is a 4x4 RAM entire thing. So as we already discussed, decoder and memory cell is nothing but, or OR gate is a combination of RAM. Now we are having a 2x4 decoder because we are using 4x4 RAM. Okay, that means 4 into 4, how many bits? 16. So totally see, count this binary cell, it is having a 16 bits. So we can able to store 16 bit of data from this 4x4 RAM. Like this we can able to design a huge circuit for a different sizes of a RAM memory. Okay, in the next class we will see the different RAM cell and how to design a RAM. Okay, so this is how we are read and write the operation. So the basic thing is this timing diagram is very important. Okay, so based on the clock, so this clock frequency is very important. We know that in computer the speed of a computer is given in frequency, you know that. So if you see in the properties, you can check the speed. So the speed may be around 2.4 or gigahertz or 3 gigahertz, right? So actually if the speed is calculated only in time, that is seconds, but how the computer speed is measured in frequency? So here the question mark. So what is the relation between time and the frequency? So frequency is inversely proportional to time. F is equal to 1 divided by t. So we need to know t, right? So how to convert? T is equal to 1 divided by f. Okay, so here we can know the speed in 3 gigahertz. So f is equal to 1 divided by 3 giga means 10 to the power 9, right? So if we take this to numerator, what happen? 1 divided by 3, which is nothing but 0.3333 etc., right? So into this 10 to the power 9 is taken to the numerator, what happen? It becomes 10 to the power minus 9, right? So this 10 to the power minus 9, what is the unit? 0.33 nanoseconds. Okay, see, this is the speed of a computer actually. So don't get confused. We are living in time domain. Computer and mobile phones are living in frequency domain. Okay, so we are living in analog domain, and the computer, mobile phones, all the electronic devices are in a digital domain. That is why they use frequency and we are using analog as well as time. Okay, so we are changing with respect to time, and the computers and all, they are constant, they remain anything, they can manipulate, edit. Okay, so we can able to recreate. Okay, everything it is possible, we can edit, right? So these are all possible only in computers, not in real life. Okay, so if I use this video and we can able to edit that video. Okay, so that type of technology now we are using. That is why this 20 nanoseconds here, you can see that in clock frequency we are giving in nanoseconds. Okay, so each time period we are having a on and off. This on period and off period is one time cycle. Okay, this on time and off time is nothing but one clock cycle. So again this on time and off time is again one clock cycle. Like this we are taking a T3. Okay, this one clock cycle is nothing but 0.33 nanosecond. What is the major hierarchical approach in computer? Actually the first thing is instruction, basic. The set of instruction become program. So instruction is the basic thing. So set of instruction becomes program, and the set of program becomes application. So and set of application become operating system. Okay, see now the operating system here, it is running right, and it is in a background there is an operating system, Android OS or this TV having a separate OS. All the OS are running basically by means of instruction. So millions of instructions are running in the background. Okay, for running the instruction, single instruction, we need a 4 different operation. What are the 4 different operation? Fetch. Okay, what are the different operation? Fetch. Second one is decode. Third one is execute, and fourth one is store. These are the 4 steps for execution of a single instruction. For execution of a single instruction we need a 0.33 nanosecond. Okay, so that is why this T on and T off is very important. I am explaining a lot of things for this understanding of this one single clock cycle. So this single clock cycle, the memory address will store all the data when the address is valid. So as I already told you, each and every person, Indian citizen, having an Aadhaar card, right? Likewise all the data having a address, that means valid address, not an invalid address, valid address. So this address is generated by means of memory address register, we see earlier in the block diagram, right? So memory enable must be always enabled throughout the entire period of storing the data. Okay, so next one is read or write. What is operation? Write operation. Now we are going to write. Actually write means, what is it called? R bar W bar. Okay, which means it is a complementary output. For giving 0 only it works. Okay, so 0 means the line is in the downside. Okay, 1 means it is in the upside. We know that. Okay, so this is 1 and this is 0. Okay, so now for 0 only this write operation will work. So the entire period of a memory storing, it is 0. Okay, last one is data input. During that time we can able to give the data. Okay, whatever data we are giving, so it will store the data. This is called write operation. Okay, next one is a read operation. So based on the time period, this is a read operation. Read is nothing but R bar W. It is a non-complementary output, so we are giving 1. Okay, the line is 1. So this is the read operation. So this is a decoding circuit. Combining a 2 different decoding circuit, we are making a huge RAM size. Okay, huge memory. Okay, in the next class we are going to design a RAM. Okay, of a different size. So this is address multiplexing. So lastly, this is a reference book I am referring, Morris Minnow, which is very useful for you. Okay, so I hope this class will help you to improve your knowledge. Happy learning. Thank you.